Hey there. So it's time to introduce an important concept, um, and it's one of two ways that we're going to learn in this course that two classes can be related to one another. The relationship between the two classes is called association. So basically, whenever you have one class, one kind of object that contains a different kind of object and holds them in its instance variables and has them as part of it, if you like, then there's a relationship of association between those two classes. And it's a really important relationship. It's important to understand how it works. And it brings us back again to the distinction between reference variables and primitive type variables. So I want to do this by showing you the example of the account class. So we haven't seen this class. This class has been kicking around in the sample code since last week, but we haven't really looked at it. So let's just take a very quick look at this class. So account is supposed to represent a bank account. A bank account is basically an ID and a balance. And you can see it also has a date created. This is an object of type date. Date is a built-in class, which we're importing up here. It's just really handy. Whenever you create a new date object like this, if you then print it, it's got a nice toString that automatically prints the current date. So I can store the date created just by doing this and then print it out later. But don't worry too much about that. What really defines a class is its balance and its ID. An account. An account also has an annual interest rate. So you can see we have two overloaded constructors here. One constructor just allows the bank to create a new bank account with a given ID and automatically sets the balance to 0. The main constructor here, though, the one that sets both, allows us to also open an account with a starting balance. So sometimes you can do that at the bank. They'll ask you to put $1,000 into the account to start, or $100 or something. So you can open an account in one of two ways, just with an ID or with an ID and with a starting balance. The date created is set automatically, and the annual interest rate is just set here to 0.5%. And then there's a bunch of getters and setters. IntelliJ folds these up. You can unfold them like this. So you've got a getter for the ID and for the balance. You can also set the balance. There's a setter for it. But more importantly, there are withdraw and deposit methods. Now these methods could do a lot more. They should probably check their parameters. You should probably check to make sure that the amount is not negative before you withdraw it or deposit it. And so on, and you should probably check to make sure that the balance isn't going below 0. So there's a bunch of checking we should really do here, but we're just keeping it simple. And then there's a toString that prints it all out. And there is also a get current interest, which just does a little calculation. The annual interest rate divided by 12 times the balance is the monthly interest. So there's not a lot. There could be a lot more here. We could apply interest and stuff like that. There's a lot more functions that we could have here, but it's just a really bare bones basic way of implementing a class that can be used to create bank accounts. The only other thing you might notice about it is the use of the keyword final here. These do not need to be final. These are not constants, but if you make them not final, you start to get these little suggestions from IntelliJ, make annual interest rate final. So what IntelliJ has noticed is that we set the annual interest rate one time in the constructor, and then we never change it ever again anywhere in the code. So it's saying, hey, maybe you want this to be final to make sure that it doesn't get changed. It looks like you want this to be set once and then never changed. If you want to ensure that, then you could wait. Let me get it back. You could make it final, and that ensures it. We're getting the same message for ID, and it makes sense for ID. We don't want an account ID to ever change. And it makes sense for the date created as well. The account was created when it was created. We wouldn't want people changing that and changing history about when the thing was created. We don't get the message for balance, though, because balance does change. It's the one variable that is being used to change. So this is just a little housekeeping measure that is often recommended when you're creating an object is even if they're not constants in the traditional sense, make these variables final if you don't intend for them to ever be changed after the constructor is called. Because again, final allows us to set it once, which it will be when the constructor is called, and then never changed. Anyhow, that's an account. So, but what I want to draw your attention to now is that there's a second class here called customer, which represents a bank account customer. And what you might notice here is that a customer has a name and two bank accounts. See, these are two variables of type account. So whenever you have this situation where one object contains references to other objects, you have a relationship of association. We say that the account class is associated with the customer class because it's holding on to, as part of its instance variables, it's holding on to, in this case, two instances of an account. And there are three constructors here. So when we create a customer, we can create them with no accounts. So we use the special value null, which is the zero value for objects. Or we can create them with one account, in which case we set the first account but not the second. Or here's the main constructor. We pass in two different bank accounts, and they both get associated with this customer. Then we have a getAccount method, which returns, see, it returns an object of type account. So it's going to return a reference. You pass in the account number. If you pass in the number 1, they get account 1. Otherwise, you get account 2. And when you deposit now, you can deposit through an account directly by calling the deposit method of the account if you have a reference to that account. But you can also deposit through the customer. So you can say, I want to deposit, I want customer C dot deposit account 1 amount $100. And depending on whether the account number is 1 or something else, we either do the deposit into account 1 or into account 2. And when we withdraw, it's the same thing. We pass in an account number, and then the toString actually prints out the name of the customer and then the two accounts. You'll notice there's some carriage returns in here as well. So that will trigger a call to the account toString method. Okay. So, and then the last thing I've got here is account test, which creates two accounts. It creates one using just the first constructor, so it's got a 0 balance. The second one has a balance of 10,000. Then it creates a new customer and passes in those two accounts that it created to be associated with that customer. And now you can deposit and withdraw. So I deposit $999.99 into account 1, and then I withdraw this amount, $83.23, from account 2. And those calls are passed on to those accounts, and then I print out the customer again. So we should see two printouts when I run this, two callings of the toString method of the customer. Whoops, wrong one. Control Shift F10. Here we go. So what we get is this is the toString. This is what we get from the toString of the customer method. If you'll notice, there were a bunch of carriage returns in there. So we get the customer and then their name, and then accounts, and then it prints out account 1 and account 2. So that calls the get method of the toString method of account 1 and the toString method of account 2. You can see their IDs here, their balances, the time and date when they were created, which is the same for both because it happens so quickly. They get the same time on them. And this is just printing the date object. So over in the account class here, the toString here prints the interest rate, the ID, the balance, and the date created, which calls the toString of the date object, which then prints out a nice date here. Actually, this whole thing is the date, including Eastern Standard Time and the year. And then I do a deposit and a withdrawal, and you can see, and then I print the customer again, and you can see the changes. So I called the customer's deposit method and withdrawal method, and it passed those on to the correct accounts. Okay, so that's the relationship of association in action. Okay, I want to show you an error here actually. This setup sets us up for potentially an error if I were to do just create Josephine Smith's account here with only one account. So if you remember over in customer.java, that calls this constructor, which sets the first account but sets the second one to null. You might be wondering what happens if I then try to deposit or withdraw from a null valued account, and the answer is that you get an exception. So I wanted to point this out to you because you might see this a lot. It's called a null pointer exception. Cannot invoke the withdraw method because this dot account2 is null. So anytime you forget to initialize something, and whether it's an array or an object, actually no, we haven't done arrays yet, scratch that. Whenever you create an object variable, it automatically gets set to null. So if you don't do the new step, you'll see this null pointer exception. So a pointer is another word for reference. So it's saying this reference is null. It doesn't have anything attached to it. It doesn't have a piece of memory attached to it, so I can't do anything with it. Anyhow, that is in a nutshell the relationship of association. And let's take a look at the guide here, because what the guide shows you is how to draw that relationship. So there are actually two associations going on here. We typically, in our UML class diagrams, we don't typically draw, I don't bother to diagram classes that are part of the system. I usually only diagram my own classes, but I put this here for completeness. So see the arrow, and notice it's an open-headed arrow. That's important. The kind of arrow is important in a UML class diagram. So this has to be an open-headed arrow, not a closed head or a triangular head or whatever. And the little 1 here means that the account class is associated with one date object. And each customer object is associated with between 0 and 2 account objects. That's because a customer can have one or both of their account fields set to null. So this is telling us, so the regular diagram, the diagram of customer and the diagram of account are the same as we've seen before. You can see all the constructors and methods here. What's missing from these diagrams, though, is I have not, the customer object, the customer class, here it is, contains another pair of private instance variables of type account. Instead of listing those here, I've represented them as an arrow to show that there are up to 2 accounts associated with this class. But that means that there must be 2 other instance variables here which represent those accounts. Some people put those instance variables in here, and some prefer to leave them out. I prefer to leave it out. So the arrow, these arrows represent instance variables. So similarly, there's an account instance variable for something of type date, and there's one of them. This number here is referred to as the multiplicity. If you leave off the number and just have the arrow, then it defaults to 1. So I didn't actually have to put the 1 here. I could just put the arrow. So the account class, yeah, there's a few notes here. Here's the important ones about the arrows. So these are association links. They show that this explains what they show, and it introduces the term multiplicity. Okay, and the type of the arrowhead matters a lot. Now, what I also want to tell you about is that I want to remind you that these are all reference variables. So in this example code that I gave you, if we just, let's see, can I do this? Can I just focus this in? Oops. Okay. I'm going to, instead of trying to do this with a whiteboard, I'm going to try and do it this way. Okay. So when we first run, the main method, the first thing we do is we create 2 accounts. So let's go back to customer test. Sorry, to account test. So I create 2 accounts first off before I create the customer object. And that creates these reference variables A1 and A2. So what I'm showing you here is I'm inside the main method, what we call the stack frame of the main method, where all of its variables live. So the main method has an A1 and an A2 variable. Initially they're null, but then I create an account object for each of them. That account object in turn creates a date object. I'm not diagramming everything here, but we have a reference to these 2 account objects, which each hold a reference to the date object. Then I create the customer object. And when I create the customer object, I'm passing those 2 references, A1 and A2, into the customer, and they get stored in the customer instance variables account1 and account2. So if I open up this screen a little bit, you can see the rest of it. I've got a reference variable that's pointing to this customer object in memory, and I have passed, A1 got passed to account1, so it also points to this account object, and A2 got passed to account2, so it points to this object. So we have a situation here where we have aliases. Even though we have aliases. Account1 inside the customer object is an alias of A1 back in the main method. And I can actually, if I wanted to, I could do deposits because I have access to, let's go back here, to A1 and A2. I could deposit right here into A1 directly. So I could go A1.deposit $100. Right? So I've reached in, I sort of bypassed the customer and just called deposit directly, and you can see that change being made over here. So you can see now it starts with a balance of $100. The first print happens after $100. So I can access the same account that lives inside the customer. I can access it out here. Now the textbook has an interesting discussion on this. They refer to this as a privacy leak because the account variables inside customer are private, which normally means that we don't allow people from the outside to access them directly. But because I created the accounts out here in the main method and then passed the references to the customer, this account is not really a private part of the customer object. It's actually been passed in from over here. Okay, so it can be accessed in two different ways. As like I said in the textbook, they refer to it as a privacy leak. And so what I want you to think about is what could you do in this case to avoid this privacy leak? How could you make it so that somehow the accounts were created in such a way as they are truly private inside the customer object? So I just want you to think about that, and we could maybe talk about that in class. We could talk about what could be done here to create these things in a different way. But I would also like to just show you one more example. So in this example, we create the accounts outside of the customer object and then pass them in. If we go back to my creeper example here, maybe I can add an association relationship here. So I'm going to add creeper world. And we'll just say that creeper world contains 3 creepers. So see creeper 1, creeper 2, creeper 3. Sorry, those should be private, like that. And then I'm going to create what I'm going to do here is, so I showed you one instance where I created the accounts outside and passed them to the customer. But the creeper world, what it's going to do is take 3 creeper names and then create its own creepers. So I'm going to do a public creeper world, and I'm going to take 3 names. Name 1, name 2, name 3, like that. Now, creeper world here is going to create its own creepers. So creeper 1 is going to be equal to new creeper with name 1. So if you remember, creepers have a bunch of different constructors. One of them allows you to just specify the creeper's name. And then creeper 2 and creeper 3 are going to be created with name 2 and name 3. And what I'll do here is maybe I'll just add a toString method, alt insert, a toString, where I print out the 3 creepers. Does creeper have a toString? I don't think creeper, oh yes it does, it has a toString. So if I go back into creeper main here, I was creating a bunch of creepers. Let's also now create a creeper world with 3 creepers. We'll call them Alice, Bob, and Cuthbert, A, B, and C. And then we'll do, creeper world CW equals new creeper world. That's what we need to do there. And then we'll do a system out print line of the creeper world, and we'll see what we get. Control Shift F10. So here's my creeper world. It's not the world's nicest toString, but you can see it's created 3 different creepers. One of them is named Alice, one of them is named Bob, and one of them is named Cuthbert. In this case, the creeper world truly owns its creepers because it created them in its own constructor. So maybe that gives you a clue as to one of the things that you can do about privacy leaks. I'm going to add and change these to /ns to make this print out a little bit more nicely. Creeper world, like that. And let's see what that looks like when I run it again. So creeper main still has my code in it from before, but yeah, here's what my creeper world looks like now. So it looks a little bit nicer. Okay, and because I own these creepers, I can do stuff. I can call their methods and so on. So what do creepers have methods for? Anything? They have a get method. So I could do, I don't know, get hearts, for example. Over here in creeper world, I could have public int, oh no, it would be a double, I think. Get hearts. And maybe what it does is just return the overall health of the world. So creeper1.getHearts plus creeper2 dot get hearts plus creeper3 dot get hearts. So I can answer Alt-Shift-L, sorry, Control-Alt-L should be. There we go. So now I can, from within Creeper World, I can call the methods of its associated objects, just like account was doing. So let's do overall health, and we'll just do cw.getHearts like that. And it should tell us the amount of hearts of each of these things. Maybe just to make it more interesting, we could go over here and, sorry, to Creeper World. And let's do times 10. Let's give them each a random number of hearts like that. So I'm going to use the other constructor to give each creeper a random number of hearts between 0 and 10. So now when we look here, we should see, yeah, these probably need some rounding, but each creeper has its own set of hearts, and it'll be different each time I run it. And its overall health represents the addition of those three. If I run it again, I'll get slightly different results. Okay, so now you have another example. The last thing I did want to do is just show you, if you're using Umlet or if you're using Draw.io, you need to know how to draw this stuff. So Draw.io has, again, its UML section that lets you draw UML diagrams. Just waiting for Umlet to start here. But if I was going to draw this in Umlet, here's what I would do. Let's make this bigger. So I would say, okay, I've got my creeper class. I would put my various things here, name, string, hearts, double, etc. I won't fill them all in just here. I've got a creeper, I've got a bunch of different creeper constructors. I've got get hearts, which returns a double, and so on. So I'm putting dots here to mean I don't want to fill in the whole thing here. I've also got, if I double click this, by the way, I make a copy of it. So I've also got Creeper World, which doesn't, I mean, it has those, it has three instance variables to hold the three creepers. It's got Creeper World, which takes 3 strings. By the way, this is always an option. If you think it's, you don't have to name the variables here. You can just say this one takes 3 strings, and it's also got a get hearts. Actually, I think that's oh, it has a 2 string as well. I think if I do this, it's going to be a full diagram. There we go. Oh, oops. Ugh. Get rid of that. That should be over in Creeper over here. There we go. We don't have any of these. Sorry, I got confused as to which was which. Okay. Still not right. Okay, this one is Creeper World. This one is Creeper. Maybe don't do that double click to copy things if you're using Umlet. Okay, does that look right? Creeper has a name and it has hearts and it has some other variables. It has some, it has a bunch of methods as well, including some various constructors and so on. So yeah, to just save some time, I'm not doing the whole thing. Creeper World over here, though, I think is complete. Okay, let me move these back around here. What I want to do now is I want to show the association relationship between these two classes. So if I double click, this is the link I want here. I want the notice the different arrow types. All these arrowheads mean something different. And notice there's dashed and dotted arrows and stuff. Make sure you're getting the right one because they all mean different things. So this is my arrow for association. I can do that. And then down here, you see, this is how you configure the arrowhead. And M1 here, I just changed that to 3 to show that there are 3 creepers associated with each creeper world. Okay, so that's how I would diagram this particular example. I'll save this UML diagram and I'll make it available as a UXF file to you guys in this week's code. Okay, but that's it. That's all I wanted to say about association. It's a really important relationship. The other relationship we're going to look at is inheritance, but some people say that association is actually more important. than the inheritance relationship, even though it's not typically considered one of the pillars, but it's an important relationship. Okay, if you go take a look at the association exercises, I think you should try these two here. We are going to look at the dating profile exercises. If I have my way, we'll look at them in class. In the live class, if we have time, we'll create the whole thing from scratch. But these, I think, are interesting exercises. This one has you play with the bank account. It has you create a customer that has a joint account, basically. So we're playing around with the fact that these are reference variables and stuff. This one is kind of from scratch. It's a small question, but it has you put together a relationship. So a summer camp has 3 tent objects. Each tent can hold up to 2 students. So a summer camp then has up to 6 students in 3 different tents. And there's objects for all of these: summer camps, tents, and students. Tents can list their occupants in a 2-string method. So the relationship between tent and students is a lot like creeper world to creeper. But then you've got this third thing, summer camp, which is associated with tents. So the summer camp can list all students registered to any of its tents. And here's the tricky part. When a summer camp is created, it's given 6 student objects. So it'll have a constructor with 6 student objects. So you'll have to, if you're testing it, you'll create the 6 students first, and then you'll pass them to the summer camp object. But it creates its own tent objects by calling their constructors, and it assigns 2 of the students to each tent. So what I want you to do here is just do a quick UML class diagram that shows the relationships between summer camp, tent, and student, and then write and test the code. We might need to take this one up in class as well. But so this is kind of a more involved one where you're testing your understanding of the association relationship. And then if you manage to get that done, you can go take a look at bank account and dating profile and so on. Try some of those exercises too. Okay, one more video to go for this week on static. And then we'll get to the assignment. Now, I'm not going to give you a video for the assignment this week. I'm going to ask you to just read it over, and we'll talk about it in class. But yeah, it's basically all based around association. So your understanding of association is going to be key, but you're going to have to use constructors and static as well. All right, I'll see you in the next video.